My name is Michael Nielsen, and I am presenting today at the Pacific Northwest Drupal Summit 2018 on Git for Teams. About me, I'm Nielsen M on Drupal.org. I'm a senior web developer at Red Hat, and I have been working with Drupal since 2007, which is Drupal 4 for everybody. So what we're going to be talking about today is Git for Teams. And for a lot of folks, Git is kind of a mystery. It's something that a lot of technologies that we all use every single day use. Git is used by some of the largest companies on the planet, including the entire Linux kernel, as well as Red Hat uses Git extensively. Just kind of browsing through GitHub, a hosted Git repository service, you see pretty much any and every company you care to think of. Facebook, Google, Apple, in some way or other, all of these companies use version control, and when they share it with the larger public, they're using something like Git. So we're going to do a brief history of Git, what happened before that, and why Drupal.org and the Drupal community at large is using Git. And then the next one will be beyond just your typical, your normal commit, push, pull type commands. Spoiler alert, commit is actually on there. There's some extra, some tactic sugar and magic that you can do with commit. That's kind of awesome. Then a kind of a fun one, how to be a total Git at Git. So this is not a best practices section, this is a worst practices section. Then the next setup, it will be getting into Git for Teams, where we're talking about merge conflict resolution, and some of the branch management methodologies that are popular in the larger community. And then we'll talk about where the future of Git is. Git is, like I said, Git is an extremely powerful technology. I think one that has potential for much beyond just uber geeks with working on the Linux kernel and developing the next big thing. I think it's going to be something that we can use pretty much anytime you're using anything written, and maybe things that aren't written. So after that, we'll go to question and answer. All right, intro to version control. How we got here. Pre-version control was, I like to call, the dark ages. And if you've ever gone through a file browser and you see things like index.php.bak or index.php.final, or a favorite one for mine is any kind of image software where you start to see things like, you start to see dashes in the file name, like a v2 or a final or a final or a final v2, which that's just kind of a contradiction in terms of, it's mildly amusing. You're looking at, for real this time. You're talking version control in the most rudimentary sense of the term. You're changing something, and then you're you're renaming the file, and that's the new one, and you can kind of keep those files in parallel, and you can kind of track and update things on an as-needed basis, and that it works. I've done more web development than I care to cop to using pre-version control, version control. It works. It's human readable. There's a single source of truth. These are really crucial things. We'll get into some of these concepts. Sources of truth, tracking files. Another great thing. If you've got 6 CSS versions you need to keep track of, you can rename those. But if you've only got one index.php, you don't need to track it. It's not in your quote unquote repo, but it's there. So you only track the files you need. It's it's human readable. Those are big pluses. The cons, No ability to track individual changes. Renaming the files. What if someone gets in there, you get a new developer on their project, and they go, I don't need all these extra, I don't know what this, index.final.php is, so I'm just going to remove it, or I'm going to erase it, or I'm going to rename it. All of a sudden, all of that version control is gone. And, with it all being up on the server, unless someone's got a local copy synced down somewhere, it's gone. And all of those, it's irreversible. Another one is it's difficult to track multiple files over time because you start to get, those file names start to get longer and more convoluted and more complicated, and so does version 1 of this PHP template work with version 3 of the CSS? And then you have to start mentally mapping things out and communicating that to the other developers on the team, or anyone else on the project, and that can get really complicated really quickly and really confusing. So, and because it's all on the server, it's a single point of failure. So, like I said, if the server crashes, the disk goes down, you need to rebuild everything. It's all gone. So, version control system, or VCS, also known as source control management, or SCM. You'll hear those acronyms kind of swapped and thrown about interchangeably. So version control system early days. So we had CVS, which is concurrent version system, and SVN, which stood for subversion. These were early open source projects in the realm of version control. They had the idea of they utilized early web technology and early web technology concepts, such as that of a server and a client. So if you needed to make changes to a repo, if you were doing some development, what you would do is you'd open your terminal, you would clone the repository down to your local machine. You would make changes to that, and then you would push those changes up. So you have a single, and the upshot to that is you have a single source of truth. So the server repository had what was presumably what was on production, and it was a single source, and you could say, this is it. This is where, this is canonical, and you could track an entire directory on and on ad nauseum. The downside to it was it didn't have a lot of ability to track multiple developers working on a repository at the same time on different things. So if you had one developer working on, say, the menu system, and another developer working on, on an article system, those had to be tracked more or less on the same branch at the same time, which meant things were kind of brittle, and developing was problematic, and it scaled poorly. So, all right, introduction to Git, and we're going to get into some jargon. I'm going to probably start spitting terms at you that are going to be really, really complicated, or that are going to be a little out of the ordinary. So for one is repo, just short for repository. The closest thing I can think of, I've spent a good amount of time trying to think of a good way to call a repository. It's just a box. It's a box to put changes and files in. So we talk about repos, we're talking about just a box. Just think of it like a box. Index. So the index is, again, to use a terrible, it's another container, but this one is more temporary. It's a bucket of changes that you're going to commit them when you finally go ahead and commit them to the repository. A remote. This is, we're getting back. This is a callback from the dark ages, not the dark ages, the early days. So it's a remote. It's something that's obviously not local. So if you're using GitHub as your remote repository, this would be GitHub. So when you're cloning from a remote, you're pulling those changes down, and so that's your remote. Diff, it's an output format. It's something that the longer you get to working with Git, the better you get at reading diffs, and they're pretty much everywhere. They're on D.O if you use Dredditor. Actually, no, they're on D.O even if you don't use Dredditor. If you click on the patch file, all patches on D.O are submitted as diffs. So you'll get comfortable pretty quickly reading patch files, reading diffs. It's something that'll let you kind of get an idea of what's going on with that particular revision. Again, local, not your remote. Pretty simple there. A commit, so it's formally adding changes to the repository from the index. So when you're finally saying, okay, I've made the changes I want to make, this is officially, I consider this to be a good stopping point. And you go ahead and you commit. So you're taking those changes, you're putting them formally into the repo, and they're going to be there. Pushing is just taking whatever changes you've made to your local repository, and you're just pushing them up. You're syncing them with the remote repository. We'll get to some fun with pushing at a later point. And branch. So it's a set of commits that are isolated from a trunk of, you could call it. SVN actually used the term trunk and branch. So a branch is something it's a set of commits that are isolated from the main line of the repository. All right. So Git history. Git development began in April of 2005. Hard to believe that. With the Linux project and the Linux kernel developers. One of the things they were using when they were developing Linux at first was a proprietary source control management system called BitKeeper. They were having problems kind of figuring out how to make that scale large thing for in a large way, because a lot of software as a service you pay by the seat, and when you have 5,000 kernel developers or 3,500 kernel developers, that's a lot of seats, and it's a big expense for the Linux Foundation and the Linux kernel to maintain that. So they decided, hey, why don't we see if we can build something similar, and we'll make it open source. So again, figuring out BitKeeper was what they were using. It was distributed. It was pretty fast, but it wasn't open source, and there wasn't anything like it in open source. So the Git team was born. For the design criteria, Linus Torvalds created out that there were going to be three design criteria. For one, take concurrent version systems, so CVS, as an example, what to do. If there's any doubt, make the opposite decision. So he was basically saying CVS is not what we want to do. Let's make something different. Support a distributed BitKeeper-like workflow, one that you could have developers that worked in a variety of different methodologies, have in a variety of different time zones, and kind of include all of those different ideas and make them work together. So one of the things that he mentioned, so the last one was include very strong safeguards against corruption, either accidental or malicious. One of the examples he uses was to apply a particular patch for the Linux kernel. It would, in CVS, it would take up to 30 seconds to apply one single patch. And in fairly common operations, they would need to apply 250 patches at one operation at one go. So 250 times 30 seconds, anyone got the numbers on that? That's 125 minutes, or approximately 2 hours. So let's say you have a kernel developer goes on vacation for 2 weeks. There's things march on, the time your project marches on, your coworkers are committing things and pushing and pushing while you're out in Hawaii or Mexico or Italy, and you come back after a week and a half off and there's 250 changes. There went your morning under normal circumstances. Just to sync up with the code base, that's pretty hardcore. So that was Linus's big idea, that we would actually go ahead and let's make something that was fast, that you could do a lot of things for, and you could do things in a lot of different ways. One of the things that's interesting, you can apply patches via email in Git. So someone could actually email. So this is something that kernel developers actually do. There is an email list that is nothing but diffs. So you can develop on the kernel. You can commit this, and you can just give it a single git command, and it will send that diff out to this list, which will then kick out to that'll kick off an email that'll send, an email chain or listserv that will send that diff to everyone on the list. And then people can then go ahead and say, okay, well, I want to go ahead and try that. So they'll get apply, and they'll just point to the email. They'll just say, go get this email and go apply the patch on it, and it'll change the code base. That's pretty radically different from a lot of other types of systems. All right. Where'd the name Git come from? It's, again, Linus quote to them, egotistical bastard, and I name all my projects after myself. First Linux, and now Git. All right, so Git for math nerds. There's something called a directed acyclic graph. If that kind of makes you go cross-eyed, don't feel bad. Basically just means that you have a series of, how do I put it? Basically that, there's nodes in a line that have a direction to it. So there are three kinds of nodes. You have a tree, a blob, and a commit. And there's a few other ones, but those are the three big ones. The blobs are basically binary data. It's whatever you've got in whatever you're tracking. Trees can contain file metadata. Who's allowed to write to it, who's allowed to read to it, the parent directory of this particular file. And then you have a commit, and that commit is basically, it's a timestamp, and that contains the blob and the tree state at the time of commit. So, and the commit also contains, funny enough, the parent. So when you create a commit, it creates something called a hash, and that hash is it's a really long string of hexadecimal digits, which is 0 to 9 and A through F. And so don't be afraid of those commit hashes. It's a commit fingerprint, and it's hashed such that they are basically one of a kind, unique. I think someone did the math on it. In order for there to be a git commit hash collision, which is where you have two commits that have the same fingerprint, it would be the equivalent of being struck by lightning while 30 meters underwater in a nuclear submarine. In fact, there was a documented case of a git commit collision about 6 months ago, and it involved about 8 steps, 4 of which were, how do I put it, less than charitable? Possibly, I would call them malicious. It involved taking a file and taking a PDF file that was in the Git repository, going in and manually editing the metadata, and then re-adding it and recommitting it. So this was not like, someone did something and we got the same commit hash. Oh no, the world is burning. It was definitely. They were trying. They actually had to find. They had the previous commit hash and had to actually edit the metadata to get those same exact values. All right. I'm gonna go ahead and post these slides online, so don't feel free. So don't worry about trying to snag the links. These are just going to be, kind of source material for where I'm getting this information. Other types of objects in Git repos are refs and tags. Refs are used as kind of like a post-it note or a marker. Probably the most one you'll see is called head. It's all in caps, HEAD, and that's basically where the very tip of your repo is, the head of your repo. And every time you make a commit, what happens is that ref gets moved. The head ref gets moved from the previous commit to the current one. So whenever you do git checkout or anything, and you say git checkout head, that you're just basically saying, hey Git, go find that post-it note that's on the commit that's at the very tip of the branch. Go get it, and here we are. So again, pushing remotes, pretty easy. You're just pushing to a remote. You're pushing those commits up to the remote, and then you're also saying, hey Git, go ahead and move that remote head, remote/head. Go ahead and move it up to the latest commit. Tags are basically just refs, but they have a little extra metadata. such as a version number, also a short commit message. So when you want to tag a release, you just git tag, v 1.0. This is the first, this is the official release. Yay, everybody, go out for a drink, or drinks are on me. That's a special kind of ref that has a little extra information, but it's exactly the same thing. And the greatest part about tags is you can then say, okay, so-and-so, you're not really a developer, you're just really interested in what's going on with the release. Just go ahead and git clone tag 1.0. Boom. They get the release. They don't get much else. And it just works. They're not on the developer branch. They're not getting any unfinished or unstable code. It's just 1.0. So this is a graphical representation of the actual what an actual node on the on a git commit looks like. So you have your git commit with the message with parents, your tree which has your file names and your subdirectory and your file name and modes, and then again there's that blob again, which is the actual changes that have been made. Why Git in Drupal? So Drupal has been around since 2001. If you remember correctly, Git was released in October of 2005, which means Drupal is actually 4 years older than Git. So there was a time when Drupal.org was not running Git clone. And in fact, it was running on concurrent version system, or CVS. And so, how did we get here? How did Drupal get on Git? Like a lot of things in the Drupal community, there was an initiative. And if you want to look at drupal.org /node/48818, that's the full, as far as I can tell, without going and trying to dig through the folks who were involved in the initiative. That's pretty much the one of the few sources you can find for rationale why they moved off CVS, what they moved to, and who was involved. You'll notice it's a great page. Kind of I was in the community shortly after this, and there was a lot of folks, a lot of big names on that page, a lot of big old names. Let's go ahead. So why move off? Why move to Git? First off, CVS was having a lot of problems. For the most part, there were only, like Angie said previously, back in the day there were only 2 core committers, her and Dries. So you can imagine how much of a bottleneck that was to get anything done on Drupal core when you only had 2 people who could actually commit those changes to Drupal core. They said it was an archaic system that no one in their right mind chooses in 2010. It was, renaming files in CVS is something, it's nightmare fuel. And another thing was, in order for developers to update their repositories, they'd have to do something called chasing ahead, which I have no idea what that means, but it scares me. So the frameworks they were evaluating to move off of CVS, one was Git, one was another open source project called Bazaar, or BZR, and the other one was the last one was Mercurial, which, if you've been around Bitbucket for a while, that'll sound familiar. Bitbucket, once upon a time, I think it still runs in some places off of Mercurial as well as Git. So those were the 3 candidates, and they basically had teams that divided up and evaluated Drupal.org's implementation in each of these frameworks. So another reason it was difficult for patch authors to have discipline to keep their patches to one context. So you had module maintainers who were trying to fix 3 or 4 issues at the same time. So what you ended up with something called a mega patch, and you're thinking of a patch that's 3,000 lines long, it has 3,000 additions and 1,200 deletions, and after a while it starts to get like, well, you just have this massive file that no one really knows what does, but it fixes all these other things, and the possibility for introducing regressions and errors just goes through the roof when you start to get things that are hard to review and hard to vet properly. Another thing was incremental git commit history. So let's say you have three or four developers working on the same thing. There's no way to step back through that and say, okay, well, developer 3 did something that was incorrect, but developer 4 who committed afterwards is doing the right thing. But we need to check out what developer 3 did. One of the last ones I talked about was committing credit. So being able to say, hey, I authored a patch on Drupal.org, I have a commit to my name. If you weren't a core committer, you weren't getting credit in CVS. So, if that's, that can be deleterious for trying to figure out who did what, and also for trying to figure out, to validate, saying, hey, I've worked on Drupal, Drupal.org, I've got, 15 or 20 commits on there, and someone says, really, where? And they say, well, I gave them to Angie, and Angie committed them. Okay. Well, Angie's got the commits. She's credited with them, but you're not. So I just have to ask Angie if you committed those. Kind of problematic. All right. So one other problem, CVS, as it said, it's not distributed, so it has to call home for a lot of things. So even as much as getting a diff, it has to touch base with the remote server to even do something as simple as a diff, which is something that Git does not have to do. You could use Git all day, every day on a plane with your Wi-Fi off, on a mountaintop, and the second you get onto Wi-Fi is the only time you need to have network connectivity for Git is when you're doing something that requires talking to a remote host, like, I don't know, pushing or pulling. So things that are obvious that need, where you need to talk to a remote, you need to do it with Git. You need to connect anytime with CVS. The last one is, again, a lot of folks at this point in 2010 were actually moving. You had module developers who were moving off of D.O for their module development and were moving on to GitHub, which was kind of watering down the Drupal brand and keeping use of Drupal.org tools was going down. So moving to Git was something that would reinvigorate the Drupal.org development community. All right. And at the bottom is a podcast wherein at about 30 minutes in, you get Sam Boyer starts talking about his process through Git migration. So like I said, so to kind of wrap up, why Git in Drupal? Drupal is an extremely distributed team, geographically and environmentally. It allowed multiple branches to run, so you had your 6.x branch and your 7.x branch and your 8.x branch, which is a lot easier in Git than it is in CVS, believe me. And then the other idea is the ability to have highly siloed access for teams. CTools maintainers aren't the same as Drupal Commerce maintainers in many cases, and being able to actually have two teams running side by side and having two different repos have different access permissions. It's a lot easier in Git. It's not foolproof, but it's a lot easier. All right, beyond Git pull and push. All right, these are the Git commands that I cannot live without. When I get onto a server and I don't have my Git aliases, it's about a half a second of panic when I get out there. A lot of times, these Git aliases are one of the first things I set up on a new local machine for myself, and I use them every day, and I've been using them for years. Excuse me. All right, so in order of decreasing frequency, let's go with git add. It's the second command pretty much anyone uses. It's a pretty common one, but there's a neat one. That -p adds up a new kind of new mode in git add. Usually when you do git add, you just git add in the file name and it just adds the whole thing and it kind of shoves it into the index. Git add -p actually opens an interactive mode that breaks up the file into individual diffs. Okay, there we are with that diff, and it basically says, okay, you're removing this line and you're adding this line, and at that point then it gives you a series of options, y, n, question mark. There's a couple other ones. But basically it allows you to do things like, hey, yeah, I want to include these in the commit, so yes. And then it kicks you down to it kicks you down to a second diff and says, okay, well, I actually don't want that one, so no. And you can just basically, instead of committing a whole file at one time, you can actually go you can just about go line by line down your file and break up all of those changes into individual commits. And you'll see the value of that later, but it's huge, because it means you can dev, make all of your changes you need to do for an entire feature, and then you can do git add-p, and you can break them all up into separate chunks, commit them separately. That way, if there's any problems with any of those disparate components, or if there's any regressions, you can basically, instead of having to back the entire work out, everything, you can just say, okay, I forgot to add a semicolon on line 5. Oh, well, I'll just, I'll revert that one commit with that one error on it, and it'll back it right up, and you'll be back where you started. Commit, again, really super common one. Git commit -- amend. So this is a good one. If everyone's done it. You commit something and you're like, oh, I forgot to add that file, or maybe you did something really not smart, like you said, fixing this stupid error for my idiot boss, and you're like, oh, there's a good chance my manager might see this. Well, guess what? Git commit amend. It kicks up. It opens up whatever browser or whatever editor you're using for your commit messages. It opens up that last commit. Beautiful and perfect. So you can be like, fixing the error from that my very smart boss pointed out in a demo this morning, and you can hit save, and that message, the previous message, gone. Also, you misspell the name of your module. Git commit amend. Change the name, add it, send it back. It's like that commit basically gets completely overwritten, and whatever mistakes you made in your previous commit, gone forever. Git checkout. This one removes commits and optionally can move to a new branch. This one also uses the -p flag, which is awesome because it means you can, but it does the exact opposite of -a. Whereas -a adds things from untracked into your index, this one removes things. So this one gets dangerous because, like it says here, there's no undo. When you check something out, it's gone forever. So, and the crazy thing about it is it's actually asking you if you want to check it out. So instead of saying yes as in adding it to the index, it's yes as in delete it. So that's the real trick right there. Is you kind of have to mentally flip, if you're git add -p or git checkout -p. So this one one's one of my first Git aliases I added was git checkout -p. That's a lot of typing. So I just said git chp, and so if I ever need to remove stuff, remove any cruft or bad bad comments or whatever, I can just do git chp on my local machine, and it opens up that patch mode, and I can just remove, get rid of all the garbage, and go back to whatever. Git status. This is a generic sit rep. Or it's just kind of a status of the what's going on with your repo, what has changed, what new files are in your repository, whatever, and it just prints it all out. This one's so special. I have not one but two aliases. I have it aliased just git s. So if I just type just the letter s after git, it'll print out status. I also have one. I'm lazy enough that I actually have a bash alias in my command line that if I type the letters G, S, and hit enter, it'll kick out a git status. So it's like, don't even have to type git anymore. It's just GS. All right, git stash. Git stash is really awesome, especially if you have managers or folks who love to interrupt you and need you to do something really, really urgent right then and there and stop whatever you're doing and work on this. Git stash is kind of like commit, but it's only local and it's not actually in your repo. It's a local only cache. So say you're working on a project and someone says, OMG, the web page is down. I think it says there's some kind of missing semicolon somewhere. And you can just go, all right, no big deal, git stash. It'll drop all of the changes you were previously working on your project into a local only cache. It'll reset you back to head. It'll, your repo is like as if you've never made any changes at all. You can go make those changes. You can fix production. You can be the superhero. You can save the day. And then after all that's fixed up, you can just go right back to Git. You go right back to whatever repository. You write it, whatever step you were in. You can do git stash pop. And it basically takes it like a queue and it just pops it off the front and it applies those changes. And it's right back, and it's basically, you're right back at the point in your repository you were the 30 seconds before, manager, coworker, whatever, came in with their hair on fire saying, OMG, the site's burning down. The danger to this is it's tricky. They're not really human. The stashes aren't machine readable aren't human readable by default, and it's easy to forget that you have an existing stash and you add another stash to that. And if you're not on the same branch you were when you stashed, you can get merge conflicts, and so you can get into a lot of trouble pretty quickly with stash. So the merge conflicts are simple enough, but it can get tricky when if you have multiple stashes at the same time because you're not sure which one's which. So kind of just keep it as for me, I keep it as like a quick, I need to go, I broke something on the site. It could be something I've done, or it could be something else. So I'm just going to go ahead and stash all my changes, retest it. Okay, it's definitely something I did. Stash pop, debug and find it. So kind of it's meant as a temporary, not as a long-term storage for repository changes. Git reset, remove changes from the index. This is a way to if you're making a whole bunch of changes and it's hopelessly broken, git reset will set you back to your latest head. If you use -- hard, it'll get you all the way back. It'll actually remove any files that have been added, and it's a hard reset. So it's basically it takes you right back to where you were from, where the branch was when you pushed it from origin. Again, like I said before, be really careful with this because there is no undo. Funny enough, also reset -p works here. So you can do patch mode. So you can change things, you can remove things really quickly from that. Go ahead.
Are head and origin the same thing?
No, head is a tag. You have an infinite number of heads. Funny, but so head is the last commit. So if you're, for the gamers in the crowd, you have a commit is a save state. So, if you've ever played a game and you die someplace and it's like taking you to the last checkpoint, that's reset head. Reset origin would be, the gaming metaphor totally breaks down here. But if for some reason, you push up to the beginning of the level, that would be reset origin. So you're basically saying, okay, everything up to, the whole level is garbage. Reset origin would be all right, I don't even want any of this that I've worked on locally. Get rid of all of it.
So when you're resetting to origin, does it then go back to the remote server and set it to that then?
What it basically does is excuse me, it's remote origin is actually another tag on your local repository. And so what git reset does is when you get reset hard to origin is you're dropping all of the commits that are different between that tag remote origin origin remote or the origin head and your local head. You're basically moving them back and you're dropping all of those commits. No, thank you.
Yeah.
All right, git log. This one's really it's pretty. It's got a lot of options and it's really crazy. But git log, it shows the changes. You can actually do some pretty neat graph type inspirations. We're going to look at some visualizations of commit histories. These are basically really pretty versions of git log. So you can it's really easy to figure out to review a history of a particular repository using git log. And funny enough, you can use -p on it, which opens it up and you can see the individual diffs of how, what all the changes that have been made over time. It gets really deep really quick. Get clean. This one's a great one for, using features. Let's say you've got a site you've inherited from someone, and they've, maybe they haven't been so great at using Drupal features, and they've got a whole bunch of, if you run drush-foo, if you run features update, and it generates a whole bunch of files that aren't tracked in the repo, and you look at them like, these are all garbage files. I don't want them, muddying up the repo. Get clean. What that does is it basically takes, you have that git status where there's a section of untracked files. Get clean actually goes through and will delete those files, so they're not muddying up the status report anymore. So there's a couple of op flags that are probably good to use. Ds is actually will remove whole directories. So if you have a plugin structure that magically generates itself and you don't want it tracked and you don't want it in the status, you can just do -d. Interactive will let you select files to select whether or not to delete those. N is a dry run, which is pretty awesome because you don't want to delete files you spent 6 hours on to make and that haven't been tracked in the repo. You accidentally do that, you just lost 6 hours of time. Problem. And then force just basically goes through and says, okay, go ahead and actually delete these things. So you'd use those last two interchangeably. You'd try it first time with the dry run, and then you'd go ahead and force it to actually go ahead and do the deletes. All right, git diff, show changes in a diff mode on anything. So you can do git diff with two commit hashes, and it'll show the changes between those two. One of my personal favorites is git -- staged, and that will show you. So you're about to commit something. Let's say you don't want to commit anything stupid. You can run git diff -- staged, which I have aliased, and it'll actually show you all the changes you need just before you commit them. So you can actually do a final review, make sure it's working, and it does that. You can also git between branch. You can dip between branches all over the place. Bisect. Everyone, as quick show of hands, anyone knows what a bisection search is? Okay. So this is kind of crazy. It's not real useful in Drupal because there's a lot of build tools get in the way sometimes. But this is a way to debug by Git. So let's say, for example, here you have you have the repos in a good state, and you just committed something, and you're like, oh my gosh, everything is broken. I don't know what happened, but there's been all these commits. I don't know which one's which. One thing you could do is you could check out. You could do a checkout to each of these individual commits and make sure that it's working. Or you could use git bisect. You could say, all right, Git, this was the last good one I know. This was the last, and it's currently bad right here. And what it does is it'll actually say, okay, there's 7 commits. It'll jump halfway through, and it'll say, hey, is it broken here? Git will basically like, is it broken? And you'll say, no, we're good. So it'll take it'll say, okay, whatever in here, this is all good stuff. So the bad stuff's in this half. And it'll basically take a point in the middle, and it'll jump to that point, and it'll say, hey, is it good here? And you can basically say, yeah, git bisect, yeah, we're still good. And then it finally jumps and says, okay, whatever happened in this commit right here, this is where the bad things happened. And so you can actually then say, okay, well, you can check out that, you can look at that commit, you can review the code and be like, all right, that's where it is. And there you have it. You've got debugging via Git. I've actually, on my GitHub repo, I have a .files that actually has all of my Git config. It's got some pretty crazy stuff in there. But all of these are pretty much, most of these are in there. So. All right. How to be a total Git at Git. We're going to run through these because we're getting close to time, so I'm going to just go fast. These are not best practices. These are, in fact, the opposite of best practices. How to be a Git. It's for those Git is a foolish or worthless person, which is where the humor comes from the name of it. Git is very powerful, but it's also dangerous. Bad commit messages. This is the next CD where you can basically go in and, garbage commit messages. Don't help anyone because you're going to read the commit messages, and if they're just like, they just say, I'm making changes, you're not going to tell I'm making changes 2 or I'm making changes 16 is where you need to actually check things out.
Quick question.
One single commit. No one wants to... Oh, yeah.
Is there a length limit to your commit message?
No.
Because it changes color after about 120 characters.
That's in a lot of... Sorry. Sorry, let me get back that up. The first line of commit message is supposed to be no more than 50 characters. You hit enter, it's unlimited after that. So you can actually, in a lot of, actually at Red Hat, what we have, so we have that 50 character limit on the first one, and then you actually hit 2 line spaces. You can do a paragraph form of the changes made, and then actually another 2 spaces, or another 2 new lines, and then a list of possible warnings. So commit messages can be an unlimited length, but you're right. You're absolutely right. The 50 characters is kind of the first. It'll be a short message just for so you can read it really quickly off of a command line. All right, one single commit. We're getting back to the usage of git add -p. If you changed 68 files with 1138 additions, could you imagine reviewing that single commit in GitHub or in GitLab? It's insanity. You wouldn't get through it. So atomic commits are crucial, not only for readability but also for debugging. Because if all those 7 commits were in one, that the git bisect would be useless again. All right.
Do you have a recommendation for size of commit that is more debuggable?
I would the term atomic I think is probably the one I use, just because it's as small as you can possibly get it. I don't do character by character. I've done 2-line commits if they're important enough. It's kind of by feel. This one's obviously kind of outlandish. I've done ones where you have 3 or 4 files changed with 20 or 30 additions and deletions of each. But yeah, it's kind of more by feel. If it's the big one I think of is the big rule of thumb I use is if I revert this, am I going to lose something I actually want? Or are there collateral damages to reverting this? If I remove this commit, am I going to change something else that's not related? All right, editor history is version control. Editor history is awesome. Control-Z is the best thing ever, but it is not Git. It's not shareable. It's if you reset your browser, if you lose your machine, there goes your version history. There goes your version control. So try to kind of keep those two separate. Force push. And not this kind of force push. This kind of force push. Git force push is an actual command or a flag you can add to git push. It's really, really dangerous because what it basically tells, one of the things that a remote repo does is it checks the state of your local repo versus its own state, and if there's any sort of funkiness where it can't move your commits onto its remote repository, onto the remote repository, it'll put up a warning. It's actually something very much like this: push, rejected, rebase, or merge. And it's saying, hey, your branches are different. You need to fix this. I'm not smart enough as a computer program to fix this, so you need to do it. Git push force basically says, it tells the remote, whatever you got on your remote, whatever your idea of this repository is garbage. Get rid of it. If my local repository is the canonical one. And it's really great because it's a way to save a project, because if someone accidentally removes the repo, but you still got it on your local machine, the project's still there. It's just not on the remote anymore. So you can do a git push force, and it restores all of that project and all of that history back onto the remote. The downside to that is if your machine is bad and the remote is good, you've just made the remote bad. So there's another option for that. It's called force with lease. You just add force-lease with lease, and that it'll kind of check and make sure that everything's going to be okay before that. All right, Git for teams. Working parallel means working on branches. When you work in a branch, you're isolated from any other branches, and that's which means if you break your branch, it doesn't break production, it doesn't break anyone else's branch. Now, the trick with branch management is when you have to merge things, and things get, that's where things get tricky. So back in 2010, a guy by the name of Vincent Dreesen came up with a management strategy called Git Flow. That post of anyone, if you're looking for Git working with teams, it's a good post to read. Talks about how to use branches in a way that teams can work together, but also that teams can work in isolation and keep their work separate as long as possible. We're going to real quickly go through the. Can everyone see this? Some of these images are kind of blurry. So what you have here, so you have your pink is in feature branches. Your yellow is what's called the develop branch, and your blue is called the master. And one of the things that's different about this is everyone usually is committing to master and pushing to master, and master is the canonical. In this one, develop is the new master. Everyone's working. The circles are commits. They're moving and they're pushing things through in time, and then they're pushing the develop. And the develop is basically where everything is tested. So the develop repo gets all of these new commits, and let's say, okay, well, we want to actually release that. So we're going to go and put it into a release branch, which then gets tagged into a release for master. And as things go, and an example of fixing bugs would be this hotfix branch. So that's actually something that's completely separate from the existing feature development workflow. All right, so an offshoot of that is something called Wunderflow, which was made by the good folks in Europe at Wunderkraut. This one's a little different. It adds a separate branch called production, and you don't have release branches. You have master, and then you release to production from master. Another one is, if you notice, unlike where you have production, where you have release branches coming from develop, the feature branches are actually fired off. The develop branch and the master branch are firewalled. You don't see any connections between the two. So you keep your features, you branch them out, and you commit to them, and you commit to develop on an ad hoc basis. But to actually release it, you push it to master, and then that gets pushed to production at some later point. Now, develop is the new master. Everything ends up there. Integration testing, QA, pre-release, all happens on develop. That's a big one there. So merge strategies, we're going to get into merge versus rebase. Scenario, your branch exists, has changes, then all of a sudden a coworker of yours is working on something similar, and you need to pull those changes in. What do? Do you merge? Which then basically creates a commit that adds those commits to your branch. That's problematic because now all of a sudden that particular commit, instead of having a single parent like every other commit you've ever made, it now has two parents. Odd. It can be time dependent. So the other option is to rebase. Rebase actually just basically tells your commit, it actually rewrites your branch history. It takes those new commits and it commits your existing commits on top of it. The best example I can use of that, so quick rule, don't use rebase on a shared branch. That's the golden rule. If you're sharing this branch with anyone or anyone else, don't rebase. Because rebase is a lot Back to the Future, wherein Marty McFly, Biff. If you remember so in the movie Back to the Future, Biff Tannen goes back and gives his teenage self a sports almanac of all of the sports scores for the next 30 years of his life. Back to the Future 2, that's rebase right there. Dangerous stuff. Merge is kind of more like previously on balance, it catches up your current branch with what's going on.
Thank you.
One of the downsides, merge, you get a lot of merge commits, and those can clutter up a branch. So, one of the ones, anytime you're working with Git, you can do something else. So what's next? Git in the future, Git beyond idiot proof for government, for biotech, for images, image handling, and then encryption. So Git accessible, making things easier to set up, making Git work almost like an autosave, where you save and it kicks up a new commit, and you do things like that. That's these are some ideas that I have. I have no way of actually implementing them. I'm just spitballing here. Auto committing, error and exception handling. Another one, beyond idiot proofing. Access control is pretty complicated right now. If you wanted to get on, if you wanted to push to someone else's repo on GitHub, you'd have to know what an RSA key is. That's not something that everybody knows or knows how to generate. So, making that ability easier to do on Git would be better. Git for government. This is from a local attendee here. This would be awesome. Changes to our laws incrementally via Git. That'd be awesome. In fact, a few years ago, the German Parliament started using GitHub for its law tracking. Git images. This would be way beyond my ken, but this would be being able to, have a Photoshop file that you could revert back to a previous state. Git for biotech. CRISPR technology is one of those things where we can start to edit. We can start editing genetic code. Well, turns out you might need version control for that. So Git for privacy, encrypted Git repos. This is something new on something called Keybase. Let's say you're editing a novel co-written by Cory Doctorow and Neil Gaiman. That's not something they want leaked out there. So if you have you could have an encrypted Git repo wherein they're pushing changes and you're just editing it, and it's in the clear, it's on the internet, but it's gobbledygook unless you're yourself or Cory or Neil. So you also use it for sensitive business documents or legal or health or even private family stuff. Here's a whole bunch of resources. I really recommend this Git flight rules one. It's probably it's fun as well as oh shit Git. There are ways to fix problems with Git repos or with a Git situation you've got yourself into, and they're step by step. They're really, really easy to read. All right, real quick, we've got a few minutes for questions. Does anyone have any?
Yeah, so going back to the thing where you said a collision really happened, what would happen in the case of should a collision actually happen?
Should a collision actually happen? On the same repository, those two commits would be identical. You wouldn't be able to tell them apart. So a Git collision would mean that there would be no way to track. If you tried to revert to that commit, you would get either or both or neither. Okay. So that's one of the reasons why it was such a panic, because you'd be really hosed.
Right. Second question is Git the people that store all of the data on the cloud, or who actually owns that?
So Git is an open source project. When you push to a Git repo, you're pushing somewhere. Whoever owns that server is where it's. So GitHub, for example, GitHub is a provider of Git hosting. So when you push to GitHub, you're sharing whatever your source code is with GitHub. So you can self-host Git. That's easy enough to do. But like I said before, there are ways to improve it. But yeah, so when you're pushing, Git is hosted places. It can be hosted any number of places. So when you're pushing to a remote Git, you're pushing your code to whoever owns that remote server. Any other questions? Thanks, everybody.